We may have just found alien life 124 light-years away on a planet covered entirely by ocean. The James Webb Telescope detected a molecule that on Earth has one source: living organisms. Today we go to K2-18b and we ask, are we alone? This is Relative Worlds, where we imagine real exoplanets beyond Earth, guided by real scientific data. Imagine that you're floating on an endless ocean. There is no land here, no shore to swim to, no bottom to stand on. Just a global ocean that wraps around the entire world, stretching 25,000 miles in every direction. You are floating on the surface of K2-18b. Above you, the sky isn't blue. It is a thick, cream-colored haze of hydrogen. And below you, an ocean that might be hundreds of kilometers deep. But the most profound discovery isn't the vast ocean itself. It's what the James Webb Space Telescope sensed in the atmosphere, a unique molecule that, on our home planet, is an undeniable fingerprint of life. You are floating on a world that might be giving off chemical hints of life, and if that's true, it would change everything. But are we seeing signs of life, or are our instruments fooling us? You are 124 light-years from Earth in the constellation Leo. Look back toward Earth, and you're seeing the Sun as it was 124 years ago, before the Titanic sank. Your host star is a red dwarf, smaller, cooler, and dimmer than our Sun. With less energy coming from the star, K2-18b has to orbit closer to receive enough warmth where temperatures could allow liquid water. On Earth, a year takes 365 days. Here, a full orbit takes just 33 days. If you spent a month here, you'd be a year older in local time. But the most surprising part is the planet itself. K2-18b is a sub-Neptune. It is 2.6 times the width of Earth and nearly 9 times as massive. We don't have a planet like this in our solar system. It exists in the size gap between Earth and Neptune, a type of world that is incredibly common in the galaxy, yet completely alien to us. Now, let's imagine what it would feel like to be here, if K2-18b has a real surface. Scientists are still debating that, because it might instead be a gas-dominated world, closer to a small gas giant than a rocky planet. But for our exploration, we'll assume it's an ocean world with a reachable surface. First, the atmosphere. You are breathing inside a Hycean atmosphere, a world-spanning ocean sealed beneath a thick, hydrogen-rich sky. The air pressure is immense. On Earth, sea level pressure is 1 bar. Here, it could be 10, maybe 50 times higher. It would feel like the entire sky has weight, like standing 100 to 500 meters underwater on Earth, except the water is air pressing in from every direction. The atmosphere is so dense, it pushes back when you move your hand, almost like moving through a thin liquid. You wouldn't be crushed instantly, but without a suit and controlled breathing, you'd likely be incapacitated within minutes. Your lungs would be trying to pull in air as dense as syrup, and the pressure would force gases into your blood the way it does to deep-sea divers. But the true brutality is the gravity. You are standing on a world with nearly 9 times Earth's mass. On Earth, you weigh 180 pounds. Here, you suddenly weigh nearly 300. But forget the number. Feel the mechanics. Your spine compresses losing fluid between the discs instantly. Your neck muscles scream just to keep your head upright. Drop a wrench here, and it doesn't fall, it accelerates violently. It hits the deck with a speed that looks wrong to your eyes. The fluid in your inner ear, your vestibular system, is being pulled down harder, confusing your balance. You feel a constant sensation of falling, even when you are standing still. If K2-18b is tidally locked, there's no normal day-night cycle. One hemisphere faces the red dwarf forever, and the other stays in permanent darkness. With a thick atmosphere, that split doesn't automatically become burning day and frozen night. The heavy air acts like a global heat engine, picking up warmth on the dayside and carrying it around the planet. The real battleground is the terminator zone, the narrow ring of endless dusk between day and night. That temperature gradient keeps the atmosphere moving. The fastest winds can roar high above the clouds, reaching around 450 miles per hour. While down at the ocean's surface, it's harder to pin to a single number. But in a thick atmosphere, even 30 to 60 miles per hour would hit with serious force. With a planet-wide ocean, the waves have unlimited room to grow. There are no continents to break the swell, just open water, day after day, storm after storm. You wouldn't get impossible mountain waves, but you could plausibly see long, rolling swells 30 to 80 feet, 10 to 25 meters high, and it's not just height, it's scale. With nothing to interrupt them, those wave trains could stretch for hundreds of miles, and the swell itself could travel for thousands of miles across the planet. So, if the chemistry is right, what lives here? Evolution is problem solving, and on K2-18b, the first problem is physics. In a 1.6 G environment, life wouldn't waste energy building tall, rigid bodies. The winning designs would stay low, spread wide, and let the water carry their weight. At the top of the ocean, under a dim red dwarf and a hazy sky, photosynthesis, if it exists, has to be greedy. So the planet's primary producers would likely be dark, spreading into floating mats and films that turn the sea itself into a living collector. Just below that, animals wouldn't be muscular sprinters. They'd be built for floating, soft, hydrostatic bodies that hold shape with internal fluid pressure instead of bones. Imagine a giant flat drifter, part ray, part jelly, wide as a room, gliding beneath the surface mats, feeding slowly on whatever the currents deliver. And where there's a grazer, there's a hunter. In the darker layers, a predator wouldn't chase, it would wait. Picture something like a living curtain, nearly invisible in the murk, sensing vibrations through the water. When a drifter passes, it folds shut in a single motion, an ambush built for a deep ocean where energy is precious. The hard truth about K2-18b is that we may never get a final answer. The life signal, DMS, or dimethyl sulfide, is still debated. On Earth, it's strongly linked to biology, especially marine life. But on K2-18b, it could still have non-biological explanations, or it could be an artifact in the measurements. But remember, it is just one grain of sand. There are over 5,000 confirmed worlds out there, and every single one breaks the rules of what we thought was possible. There are planets made of solid diamond, planets where it rains glass sideways at 4,000 miles per hour, planets that wander through the dark void without a star, frozen in eternal night, and planets that are burning so hot they are evaporating into space. This channel has one mission: to take you to the surface of every single one of them, to feel the gravity, breathe the air, and witness the impossible. We are leaving Earth behind. We are hunting for new homes, new dangers, and new life. So if you're up for this journey, drop us a follow and see you every week on a new exoplanet.